I'm Tom from Do-It-Yourself Home Automation, and I'm super excited to share my new solar-powered cryptocurrency mining computer. So I've been working on this for a while. It started with my off-grid solar panel system, and I've added on a crypto mining computer. And why would I want to do this, I think is the first question. Really, as people have been doing more mining, there's more of a realization that the environmental cost of mining cryptocurrencies is very high. So right now, the Bitcoin network alone uses as much power as many countries. And so that results in a huge amount of carbon emissions and a lot of environmental impact. And one potential solution to that would be to use renewable energy to mine crypto. And it's actually, I think, a great way to especially use off-grid solar panels in inexpensive places that get a lot of sun to generate cryptocurrencies and create profit from these off-grid solar panel operations. So I want to demonstrate that at a small scale. I also want to show how this could work for an individual miner at home. And so what I've done is to build this solar panel system connected to a cryptocurrency mining computer that is actively mining at the moment, and I'm going to walk through exactly how I did that. So let's start with the solar panel system itself. This is an off-grid system that I built using panels from Renogy. Renogy is a company that sells off-grid panels for use in mobile homes, camping, boats, that kind of thing. And these are really great, well-built 12-volt panels. They should last many, many years. And they're really easy to set up. This is not connected to my house in any way. It's just sitting out here in my backyard. You can see it's in full sun right now. And I've got a 100-watt panel from Renogy over here. It's about $100. And then I've got three 50-watt panels, each about $50 from Renogy. Ideally, I would have panels at the same wattage. I'm probably not getting an optimal output from this. 250 watts theoretical power, 100 plus 3 at 50 each. Probably in reality, I'm getting about 200 watts out of this. So again, if I did 2 bigger panels or 3 bigger panels, I'd probably get better output, but this is what I happened to have purchased for other experiments. So all of these panels are going into a MC4 splitter on the back, and that is combining the output from these into 2 MC4 cables, sort of industry standard, and combining them in parallel. So if I wired these up in series, I'd be taking the 12 volts from each and adding them together. Instead, by wiring them up in parallel, I am getting the same 12 volt output, nominal output, but I'm actually combining their amperage. So I'm combining all of that, the power coming out of them, getting a higher amperage at the 12 volts nominal output. And that's coming into cables. They're tucked away behind here. You can see some of them down at the bottom here. I don't want to move this out of the way right now. It's going into this Adventurer solar charge controller, also from Renogy. This is not a waterproof controller, by the way. This is under a little overhang on the side of my house, so it doesn't get wet. But the power is all coming in here. And you can see on the readout here some information about what's happening. And so if I scroll through here, I can see the different settings here. So let's start. The panels are generating 12.5 volts. So that's a good output there. And then let's take a look. The panels are outputting at the moment about 7 amps. We'll get into why that is in a little bit. And then let's take a look at the amount that they've generated so far since I started this particular round, 1.6 kilowatt hours. And then my battery voltage, 12.6 volts. Again, we'll take a look at that battery in a second. And the battery temperature. I don't think this is actually connected at the moment. But basically, this is taking in the power from these panels, and it's using it to charge a battery and getting that power ready to actually use. So all of that is coming from the Adventurer charge controller into this Renogy deep cycle battery. And this is it's in a battery case to keep it protected from the elements, but this is a deep cycle solar battery from Renogy. And it's useful to use a battery that's specifically tailored for use in solar panel systems, so that it's something that can be discharged and recharged over and over again without having any kind of damage there. So this is specifically designed to be connected up to this charge controller. We're getting power into this battery from the solar panels, and it's keeping that topped up. And again, I built the system originally to be a mini off-grid system for use during public safety power shutoffs, which we get here in California. We get these rolling, outages. Sometimes the shutoffs can last a couple of days. So I wanted to have a power system I could use, power appliances, and so normally in normal times I don't need that. And again, it's a great way to leverage that power to use it to mine crypto. So going into this deep cycle battery, it's storing the power. And it's important to have a battery for this mining operation for a couple of reasons. One of them is that right now we're in full sun and it's a bright sunny day in California, but imagine a cloud went in front of these panels, or even a person walked by and their shadow ended up on the panels for a couple of seconds. That could drop the output from the panels low enough that it wouldn't be able to run my computer, which again we'll look at in a second. And that would be really annoying because every time a cloud came out, the whole system would be shutting down and then starting back up again over and over. And so the battery offers some buffer because this charge controller is charging the battery's supplying power, and it's got enough charge in there to last for a while. So even if there's intermittent clouds or it's not a fully sunny day, I can continue to mine and my computer's not shutting off over and over again. It's also good because it gives me a bit of a buffer on the beginning and end of the day. So I can mine as long as the sun is out and I've got, pretty much full or partial sun on these panels, but charging up and topping up that battery gives me some extra run time at the beginning and end of the day where I'm running on battery power, and that ekes a little bit more profit out of the system, which again we'll get into in a bit. So there's the power going into the battery, and then the next step is this Renogy 500 watt power inverter. So the power in this battery is 12 volts, and that is not actually, computers run on 12 or 5 volts, but the input to a typical mining computer is 120 volts from the wall in your house, so it wouldn't be able to run right off of the battery without modifications. So instead what I've done here is use this power inverter, which takes in the 12 volts of the battery and turns it into a standard 120 volt outlet here. And that makes it easier to connect up my computer to the battery. It also means that during a power shutoff, I can use this system to power normal appliances, lights and the computer or work and that kind of thing. And that's really helpful to have this inverter for that purpose as well. So again, this is a dual purpose system for me. In good times, it's for mining. In bad times, I shut off the mining PC, and if there's an outage, I can use the power from this to run other appliances. So this is taking that 12 volts, making it 120 volts. You do lose a bit in the conversion, probably around 10% of the power, so there's a bit of a power loss, but I think that's the price to pay for that conversion. Now the power comes out into this extension cord, and this goes behind the panels, runs along the wall here, and it's taking the power into my garage. And I just don't want to have the mining computer out in the elements, so we'll follow this extension cord into the garage. Okay, here's the terminus of that cable. I'll probably make this a little prettier looking, but you can see it goes into this kilowatt hour meter that we'll look at in a moment, and then up and into my mining PC. So here's the mining PC. I've talked a lot about this in other videos. So this is a custom build. It's based on a bill of materials from my friend Adam, who's a computer engineer. So thanks to Adam for designing a really nice bill of materials here. And when you're building a simple mining computer, basically the computer itself should be as cheap as possible because it's basically just a wrapper around this. This is my GPU. This is a NVIDIA GeForce GTX 1070 GPU, and that's what's doing the actual mining operation. The rest of the computer is really just there to assist it. And so to run the operating system, to connect to this and run the software that's doing the actual crypto mining. And so really you want it to be as inexpensive as possible. That means you want to build it yourself. And again, this is a really simple build. So it's just a gigabyte motherboard, really basic motherboard, and it's A320M. We've got a simple AMD processor on there. We've got an 8 gigabyte RAM stick. Originally I tried an M2 memory stick. I couldn't get mine to work. I don't know if it was a driver issue or if it was just a bad stick. So instead I just repurposed an old SATA drive that I've got plugged in here. And then the whole thing is in a Rosewill case. Really easy, simple, cheap case. There's two things I invested in. Again, the actual GPU, which again these days can get pretty expensive since crypto is kind of taken off. And I also invested a bit more in this EVGA Supernova Platinum power supply. So this is a very efficient power supply. The name of the game is to get as much power for mining out of as little input power as possible. So I thought a Platinum power supply would help to do that. And again, great bill of materials. I put this all together. It was really easy. I've shown that in other videos. The only thing I did wrong was I forgot to put the standoffs on the motherboard the first time around, so it was shorting out on the case. That may have bricked the M2, I'm not sure, hopefully not. But in any event, once I fixed that issue, it was fine. I installed Windows on it. I just got this USB stick with Windows and installed that on the computer. And the total cost for this bill of materials minus the GPU was $249. So that's about as efficient as you're going to get from a price perspective of putting this together. You could go even cheaper if you eliminated the case and did a bare board, for example. You may be able to get even cheaper components or repurpose existing components. But for a brand new build, super easy to put together. All of this I sourced on Amazon. That's a really good low price, and again, it was pretty simple to assemble. The GeForce GTX 1070 I got several years ago now. Still does a great job mining, and it was $349 when I first got it. So the total cost on this guy is about $600 for the PC, including the GPU. So let's see what it actually looks like. Because right now it's mining. Let's see how that looks. So to do the actual mining, I'm using NiceHash. This is NiceHash. It's a easy to use software. It's a one-click operation. And instead of doing the mining directly, you're actually selling your hashing power that other people can then buy and use to mine the currency that's best suited to your computer. And it's basically like a pool of hashing power, and you're selling that hashing power. So in my case, it's probably mining Ether, I would guess, based on my configuration. And it's using that GPU to do that mining operation. And you can see it's making $2.50 rather per day of profit. And this really is pure profit. Normally you have to factor in the cost of electricity, but because this electricity is coming from solar, from my panels out there, I'm actually not having to factor that in. We do have to, of course, think of the overall system cost. I'll get to that in a minute, but once you actually got it up and running, this is just pure profit. My average is based on crypto prices and the demand for hashing power, and also the power of your actual hardware. My average is actually closer to about $3 per day. You can see even as we're looking at this, the prices are fluctuating. I find it's usually about $3 a day on average. And you can see to do this mining, it's using this NVIDIA GeForce GTX 1070, and it's running it at full blast. I could probably use software like Afterburner to eke a little bit more performance out of that card by tweaking the power settings, overclocking it a bit, but this is just a total stock build, and I'm still getting, again, on average at the moment, it's like 250.2 there, and on average I'd say it's about $3 a day of profit from the mining. So let's take a look at what kind of power we're using and at the overall picture here. So here's my kilowatt. You can see it's using about 150 watts to do this mining. That's really good. That means the computer itself is probably only using about 50 watts, and most of that power is being used by the 1070. And again, I could probably overclock, bump that up, and get even more juice out of that. It would increase my wattage here, but I could probably do that and get a bit more mining performance. But 150 watts coming in here, that's a pretty good power consumption, I think, for the amount of profitability I'm getting out of this mining. So let's go back to the solar panels, and we'll talk a little bit about what they're outputting and also the overall system cost and considerations there. Okay, so here we are back at the solar panels, and you can see we're getting still pretty consistent performance. We're generating about 5 amps right now. Battery voltage has stayed fairly consistent there. And why are we only getting 5 amps when the system can output 200 watts, which should be probably, that would be what, 15 amps or something like that. The reason for that is that I started with this battery fully charged, and your panels are only going to output power proportional to the load that they're under. So because the battery is fully charged and we're using only about 150 watts from the mining computer, I'm not really putting a lot of load on these panels at the moment. So they're just providing enough power to keep this battery topped up, not run it down too much. But if I'd started with a totally depleted battery and we were pulling 150 watts out of it, then presumably these would be generating enough power up to their capacity to recharge the battery and to run that computer. So one day I'll try fully discharging, or actually you don't want to go fully, you only want to go about halfway to avoid battery damage, but I'll try halfway discharging this battery and then running this, and we can see if the amperage bumps up. It definitely should. But in any event, they're supplying definitely enough power along with this battery to continue to mine indefinitely as long as the sun is out. And that part's important. Again, remember it was about $3 a day on average I would be getting from the mining if I was running all day. But in practice, I can really run for about as long as the sun is out, which is usually about 7 hours per day here in California. This is south facing, so I'm getting full sun, as long as the sun is out. And then with the capacity in the battery, I can probably add another hour or so of mining to this. So that's definitely something to keep in mind. That means that my actual earnings per day are more like $1 when this is running. So again, because there's no electrical cost, that's just all profit minus the cost of the system. So let's look at the overall picture there. As I said, the bill of materials for the computer is about $250. The GPU is about $350. And so that's about $600 for the mining PC. I'm not counting the cost of the monitor, and I'm not counting its power consumption because I wouldn't normally use it. I just wanted to plug it in so you could see the readout of what I was mining, but normally I'd leave the monitor out of that, and I would access the computer through a remote desktop, so I don't have to use the power from that monitor to account for that in the overall picture here. So about $600 for the PC. Again, it's about $1 per watt for these panels, so it's about $250 there. And then the battery and the inverter or the charge controller was about another $250. If you use something like a car battery, you could get that lower. Again, because this is a dual purpose system for me, I wanted a deep cycle solar battery so that I could use it for my off-grid system in the event of power outages. But you could probably go lower if you used lower end components for this part of it. In any event, though, about $500 here, about $600 for the computer. The total system cost is about $1,100. Now, remember that I'm generating about $1 per day, so that means it's a little less than 3 years of runtime. I would make back the total system cost: panels, battery, charge controller, computer, GPU. The whole thing would be paid off, and beyond that, any mining I did for the lifetime of the system would be totally pure profit. That's not bad, honestly, for something that's at this small of a scale. It's probably not super practical for most people to build something like this, but I think it's a good proof of concept that even at this tiny, tiny scale, you're looking at a sub 3-year turnaround to replace or to pay off the entire system. Now, a couple of factors could change that. If crypto prices went down, then I would need to mine for longer to be able to recoup the cost of the system. However, if crypto prices go up, then my payback time would probably be a lot shorter. So it could be as little as a year if Bitcoin doubles again. Some people think it could. I have no idea what crypto prices are going to do in the future, so there's no way to predict that. I know when I first started experimenting with Bitcoin mining, Bitcoin was about $3,000, and now it's around $50,000, so certainly that can happen, but of course it could go in the other direction. But that's one thing to factor in. I could mine all this and it could double in value or more, or it could go down, and then my runtime to recoup my cost would increase. But I think the more important thing this demonstrates is, again, that even at a very small scale, it's possible to mine using solar power, and to do it in a way where the replacement cost for the system is not that long. And if we added in, for example, another GPU to that computer, bumped up the number of panels to accommodate that, You could probably reduce that and get even more efficient operation out of that $250 computer, because you wouldn't have to rebuild the whole computer to just drop in another GPU. You could probably get bigger and more efficient panels, and you can start to see how you could scale this up to something that would be, if not necessarily grid scale, something that could, be a solar farm size. And one of the great things about using solar power for mining crypto, again, it eliminates an environmental cost. You're looking only at the environmental cost of manufacturing these panels and components, not at the ongoing carbon emissions of the electricity, because this is all just coming from the sun. So that makes all of the Bitcoin that I'm creating there cost-free in terms of carbon emissions, or much lower cost anyway than if I was using electrical power that was coming from coal or from another dirty power source. So that's really great from an environmental perspective, and I think it demonstrates that you could use solar to do crypto mining and actually make that a good use of renewable power, an incentive to generate renewable power. But the other thing I think is great here is that this is a proof of concept of an off-grid system. So you can imagine, this is something you could do in the middle of the desert where land is super cheap. Just put up a ton of solar panels, feed them into some batteries, run them into a mining farm, out in the middle of nowhere. And you wouldn't have to be tied to a grid. You wouldn't have to be negotiating contracts with a utility to sell that power. You could generate it, use it to mine crypto right there, and immediately be making profit from that. And again, efficiencies of scale. If you scale this up massively, I think your economics will look even better. But again, I'm pretty happy that, even in my tiny scale here, it's a sub 3-year time period to pay back and break even on the system cost. So I think there's a lot of potential that you could pursue with something like this. And there's also some advantages just at the kind of local scale. And that's the fact that I built the system, to be an off-grid solar panel system in the event of an emergency or a power outage. And by adding in the mining component, I'm basically paying for that system. So I'm not just having this useless capacity that's sitting around not doing anything on a day-to-day basis. I can use this to mine some Bitcoin, hopefully ultimately make some profit. And then because it's a dual-purpose system, if there's a power outage, I'll just shut off my mining computer, and I've already got great off-grid solar power that I could use for lighting or for running my work PC to continue working through an outage. For any other purpose that I need. So yeah, I'm really excited about demoing mining crypto on solar power. You can see a lot of ways that this could be scaled up, but even for me at this small scale, it's already a functioning, helpful system.